Good morning, everyone. Thank you for coming. This lecture is talking about second part of chapter 2, force vectors. Please listen very carefully the lecture. Today we have 4 learning goals. Basically, we are going to learn how to express forces as scalar notation and Cartesian vector notation. Next, we will learn how to find the resultant force for multiple coplanar forces. Lastly, we practice to be familiar with this scalar and Cartesian vector notation by solving 3 examples. First, let's look at rectangular component. You may remember that we learned parallelogram law last time. That is, we can express a resultant force F as Fx plus Fy. Based on the parallelogram law, you can see this and the resultant force F. You can see the image. This image shows resultant force F with a blue color. The other 2 components, which is rectangular components Fx and Fy along the x and y axis respectively. They are rectangular. And one more thing is that there is a theta. Theta is an angle of resultant force relative to a certain axis. So in this case, the theta is an angle between the resultant force and the horizontal fx. Okay, we can express this rectangular component as a scalar notation and the Cartesian notations. So let's look at the scalar notation first. As we learned last class, a scalar has a magnitude, but it does not have a direction. But in the scalar notation, we can put plus or minus a sign to the magnitude so that we can assume a direction of the vector. So for example, on the left-hand side images, the Fx is a resultant force times cosine theta by applying trigonometry. Then what is Fy? What is Fy here? Fy is F times sine theta. This is a basic rule of trigonometry. We have to know this rule throughout the whole semester. Let's look at the right-hand side figures. You can see that the direction of the resultant force is positive x-axis and negative y-axis. More importantly, there is no angle. There is no angle information. But we have a length information of a triangle. So CBA. So this A and B, the angle between A and B is 90 degrees. So we can use this information as a cosine and a sine or even tangent. Alright, so Fx here is Fx is F times A over C. Right? Because of the cosine rule, it's A over C. How about Fy? Fy is F times B over C. But remember that this is a negative direction of y, so there is minus sign. Let's look at the Cartesian vector notation. Cartesian vector notation is the same thing. The resultant force F is equal to Fx plus Fy, but there is I and J. And what is I and J? The I is a unit vector of x-axis. You can see this is x-axis, and J is a unit vector of y-axis. So it's talking about the direction. I will explain what is a unit vector in the next class. But all you need to know is I and J is talking about the direction. So I is talking about x direction, J is for y directions. Okay, so F equal Fxi plus Fyj. It's a Cartesian vector notation. Okay, so coplanar force resultant. So for example, we have three forces, F1, F2, F3. So we have multiple forces. It's more than 2 or 4. It can be a 5 or 6. In the scalar notation, we can simply express each vector like this. So F1 is F1x plus F1y. F2 is minus F2x plus F2y. And F3 is F3x minus F3y. Okay, because of the direction. How about the Cartesian notations? So F1 is F1xi plus F1yj. F2 equals minus F2xi plus F2yj. F3 is F3xi minus F3yj. Therefore, the resultant force of these three vectors components is F1 plus F2 plus F3 by the parallelogram law. Okay, we can express this form in Cartesian vector notation just like this. So F1 is F1xi plus F1yj plus minus F2xi plus F2yj plus F3i minus F3yj. Okay. So you can see that F1x minus F2x plus F3xi, okay, plus F1y plus F2y minus F3y and j. We can simply add or subtract the x-axis and y-axis component separately. This is the most important concept of the Cartesian notation, which means you can just sum up all the x-axis component together and the y-axis component together to find the resultant force. Okay. The resultant force is like this. Okay. So resultant force x is the summation of all the x component of the x-axis component of each forces, and the resultant force y direction, the summation of all the y component of each vectors, each forces. Okay. The magnitude and the direction of resultant force can be calculated based on the Pythagorean theorem and arctangent respectively. So this is the magnitude of resultant force and this is the direction of the resultant force. I guess every one of you have heard about this Pythagorean theorem. Under this rectangular vector component, which means frx and fri are in 90 degrees, which means it's a right angle, we can apply Pythagorean theorem to calculate the resultant force, the magnitude of the resultant force. So Fr, the magnitude of Fr is square root of Frx square plus Fry square. At the same time, the theta can be calculated by arctangent. The theta is equal to arctangent Fry over Frx. Let's solve a problem together. determine the x and y component of F1 and F2. Express each force as a Cartesian vector notation. As a Cartesian vector notation, F1 can be expressed as F1xi plus F1yj. So in this case, I is the direction of the x-axis and the j is the direction of the y-axis. For the x-axis direction, F1 is directing, you can see F1 is directing the negative x-axis, and there is an angle 30 degrees along with the y-axis. So F1 can be expressed as 200 Newton times cosine 60 degree. This is the 60 degree. So cosine 60 degree is along with the negative x directions, and 200 times cosine 30 degree, which is along the positive y directions. How about F2? F2 is 260 Newton, positive x direction and negative y directions, and there is no angle, but we can use this length information to calculate the directions. So in this case, F1 is 200 Newton times cosine 60 degree minus, so that is 100, plus 200 Newton times cosine 30 degree, which is positive y direction, that is 173J. Okay. For F2 is 260 Newton times, there is no theta information, so we use this information. What is that? 12 over 13. Okay. 260 Newton times 12 over 13, that is for x component. And for the y component, 260 Newton times 5 over 13. So that is minus y directions. That's why there is minus. Let's solve another example together. The link is subject to two forces F1 and F2 determine the magnitude and the direction of the resultant force. So this is the problem. Determine the magnitude and the direction of the resultant force. So we need to calculate what is the resultant force from these two forces. Okay. So F1 has 600 Newton, F2 has 400 Newton, and this is the directions, the angle relative to the x-axis and y-axis. So let's express these vectors, force vector, in a Cartesian notation. For the F1 is 600 Newton times, for the x component, 600 Newton times cosine 30 degree. So this is the x component of the F1. How about the y component? 600 Newton times sine 30 degree. So this is the sine 30 degree. So this is the y component. F2, you can see the x component, x direction is negative x-axis. So minus 400 Newton times, you can see the 45 degree here. This is another 45 degree. Sorry, another 45 degree. So it's you can say either cosine 45 degree, or you can also use this 45, but in this case we can use sine here to calculate x component. For the y component, 400 Newton times cosine 45 degree. So in this case, 400 Newton cosine 45 degree J. Okay. So we express this for F1 and F2 in a Cartesian vector. So again, resultant force Frx is sigma of all the x component of each forces, and Fry is the summation of all the y component of each forces. So F resultant force is F1 plus F2 based on the parallelogram law. So F1 is this and F2 is this. We can make a summation for I. Oh, sorry. So F1 plus F2. Actually, this one is not just F1. This is a summation of x component of F1 and x component of F2. And this one is y component of F1 and the y component of F2. So you can see that this is summation separately for I component and j component. This is direction. So the answer is 236.8I, which means x direction, positive x direction, plus 582.8 j, which means positive y directions. This is Cartesian vector notation of resultant force. Okay, so once we got this, then we can calculate the magnitude of the resultant force using the Pythagoras theorem. So just the square root of 236.8 square plus 582.8 square, which means 629 Newton. The direction is theta. We can use arctangent. So arctangent 582.8 divided by 236.8, which means the theta is 67.9 degree. The last example is that, okay, there are three forces acting on the boom O. Determine the magnitude and the direction of the resultant force. So basically, what we are going to do is that express each force in terms of x and y direction in Cartesian vector notation and make a summation for all x and y components of each force to find the resultant force. And then we can calculate the magnitude and the direction of the resultant force. Okay. Let's express the three forces F1, F2, F3 as Cartesian vector notations. Again, the resultant force Frx, the x component of resultant force, is the summation of all the components, x components of each force. Resultant force Fry is summation of y components, all the y components of each force. So for the F1, it has only, you can see F1, it has only x directional movement. There is no y-axis component. So the force is just minus 400 Newton I. For the F2, the x component of F2 is 200 Newton times, there is a 45 degree, so it's a cosine times cosine 45 degree along the x-axis, positive x-axis. For the F3, the x component is 200 Newton times 4/5 along the negative x-axis. So the x component of resultant force is a summation of all the x component of each force. So this. For the y component, here F1 we don't have a y component, so that means it's 0. There is a 0 here. This is the y component of F2, 250 times cosine 45. You can see the y direction. This is positive y directions. Newton plus 200 times 3/5 Newton. It's also positive y direction. So this is the answer. To calculate the magnitude of the resultant force Fr, square root of minus 383.2 Newton plus 296.8 Newton square, then we can calculate 485 Newton. To calculate the direction, we can use arctangent. So you can see that 268 over 383.2. So that is 37.8. Today we learned scalar and Cartesian vector notations, and we know how to find the resultant force from 3 different forces, and we learn how to calculate the magnitude and direction of the resultant force. Thanks for watching this short video, and have a great day.